everyone. Good evening all of you. Today we are going to solve the questions on steam turbine. आज steam turbine पे question solve करेंगे. Today we are going to solve the questions on steam turbine. Are you all ready to solve the questions? Have you all studied the concept of steam turbine, that is impulse turbine, reaction turbine? Have you all studied that? Have you all studied the formulas? Have you all studied the formulas? Do you know the maximum blade efficiency for impulse turbine, maximum blade efficiency for reaction turbine? Do you all know these concepts? Bologe. So let us start the today's class. First of all, introducing myself. My name is Harshit Agarwal. I have around 7+ years of teaching experience. I did my engineering in mechanical from NIT Nagpur. I have cleared the ESC examination twice with rank 63 and rank 90. Got the highest marks among all the candidates in UPSC interview. Mentored more than 30,000 students, and my area of expertise is thermodynamics, RAC, IC engine, power plant and industrial engineering. So starting with the very first question. This particular lecture is related to questions only, so I cannot teach you the theory. The theory classes are being conducted in the morning for these sessions, and in the evening question sessions are conducted. Right, so we will be directly proceeding to the questions. So all of you give me the answer to question number 1. Maximum possible efficiency of a D-level impulse steam turbine when nozzle angle is 22 degree. कितना होगा उसका maximum possible efficiency? बोलोगे? क्या formula होता है? What is the formula? D-level is a simple impulse turbine. So what is the maximum efficiency for the D-level turbine? Maximum efficiency is equal to cos square alpha. This is the direct formula. Cos square alpha, where alpha is the nozzle angle. Where alpha is the nozzle angle. So what is the answer? It is equal to cos square 22 degree. It is equal to cos square 22 degree, which is coming as B. कैसे आएगा? 86% आएगा ना, which is coming as around 85.966, which is equivalent to 86%. That is option number D. B कैसे आ रहा है? जीवन, रणबीर, शिवम, बी कैसे आ रहा है आप लोगों का? अच्छा, cos स्क्वायर 22 डिग्री है ना, तो बी कैसे आएगा? परविंदर, कितना आ रहा है एग्जैक्ट आंसर? परविंदर एक बार बताओगे? परविंदर, कैन यू टेल मी व्हाट इज द एग्जैक्ट? यही आ रहा है परविंदर, यही आ रहा है आंसर? राइट, so the correct answer is option number D. I don't know why you people are getting the B answer. Now tell me the answer for question number 2. Have you studied nozzles? If you are not studied, so the next series I will be starting the steam turbine series and nozzle series. Right, so what is the nozzle efficiency? Is described as isentropic heat drop by Uchiha, isentropic heat drop by useful heat drop by isentropic heat drop, saturation temperature by supersaturation temperature by saturation temperature. Can any one of you give me the answer? See, that is why you people leave these topics. See, these questions are asked very rarely in the examination, but they can be asked. So nozzle efficiency is described as useful heat drop by isentropic heat drop. Nozzle efficiency is described as useful heat drop by isentropic heat drop. So the correct answer for question number 2 is B. Question number 3. Now this is the Parsons reaction turbine. This is a reaction turbine. In Parsons reaction turbine, steam at 200 meter per second is expanded to a pressure of 140 kilopascal. What is the speed of steam? Speed of steam is 200 meter per second and it is expanded to a pressure of 140 kilopascal. Nozzle angle is given as 20 degree. All of you share the session. Nozzle angle is given as 20 degree and rotor is running as 3000 rpm. nozzle angle is given as 20 degree and rotor is running at 3000 rpm. Calculate the maximum possible efficiency. He is asking for the maximum efficiency. So for maximum efficiency, do you remember the direct formula of reaction turbine for maximum efficiency? Do you remember? Is there a need for velocity? Is there a need for pressure? Is there any need for RPM? एक बार रिकॉल करो डायरेक्ट फॉर्मूला रिएक्शन टरबाइन का. एक बार रिकॉल करो डायरेक्ट फॉर्मूला रिएक्शन टरबाइन का. All of you recall the direct formula. So the maximum efficiency for reaction turbine is 2 cos square alpha upon 1 plus cos square alpha. 1 plus cos square alpha. This is the formula for reaction turbine. So what is alpha? Alpha is the nozzle angle. What is alpha? Alpha is the nozzle angle. So it is going to be 2 cos square 20 degree upon 1 plus cos square 20 degree. So you will be getting the maximum efficiency. What is the maximum efficiency? Maximum efficiency you will be getting as 93.78%. This is going to be your maximum efficiency, that is 2 cos square alpha upon 1 plus cos square alpha. Right? Is this clear to all of you? So let us proceed with question number 4. All of you solve this question. Which of the following options are correct regarding stagnation state? Stagnation state पता है क्या होता है? जब velocity बिल्कुल जीरो हो जाती है. Stagnation state में, at stagnation state kinetic head is 0. There are two answers to this question. There are two answers to this question. At stagnation state kinetic head is 0. B, during energy transformation, stagnant state of fluid change. During energy transfer, stagnation state में सबसे पहले kinetic head तो 0 होता ही है. तो ऑप्शन ए तो है ही. और मैक नंबर, अगर मैक नंबर भी 0 होगा, मैक नंबर इज इक्वल टू वी बाई सी. अगर वेलोसिटी 0 हो जाएगी तो मैक नंबर भी 0 हो जाएगा. मैक नंबर इज ऑल्सो गोइंग टू बी 0. सो द करेक्ट आंसर इज ऑप्शन ए एंड डी. ऑप्शन ए एंड डी. एट स्टैग्नेशन स्टेट kinetic head is 0. At stagnation stage Mach number is 0. So for question number 4, option number A and D both. Question number 4, option number A and D both. Clear है? Yes. नहीं, वो कुछ नहीं होता है. नो नो नो. क्वेश्चन नंबर 5 का आंसर बताओ. क्वेश्चन नंबर 5 का, विच ऑफ द फॉलोइंग स्टेट आर ट्रू फॉर रीहीट फैक्टर? रीहीट फैक्टर. Do you remember the formula for reheat factor? Do you remember the formula? See, I cannot explain you the concepts here. It is not, because this is related to questions only. If I will be start explaining you the concepts, so only one question will be solved. Right? We have to do several questions. So first is correct. First is correct. It is the ratio of cumulative enthalpy heat drop to isentropic enthalpy heat drop. B is also correct. Just recall the formula. It depends on initial pressure, क्योंकि वहीं से enthalpy आएगा and condition of steam. वहीं से pressure आएगा. Stagnation state mean when the velocity is 0. When the velocity is 0, flow is suddenly stopped. Yes, this is multiple select question. This is MSQ. This is MSQ, multiple select question. Then it decreases with increase in number of stages. No, this is not true. Who told you this? This is not true. And yes, this is also true. Its values varies from 1.04 to 1.08. It values varies from 1.04 to 1.08. ये बहुत ज़्यादा इम्पोर्टेंट है. ये बहुत ज़्यादा इम्पोर्टेंट है. right? So let us do question number 6. All of you solve this question. All of you solve this question. Steam flow at the rate of 5 meter per second, 5 meter cube per second at a particular section in a reaction turbine where the diameter of the blade is 2 meter. The diameter of the blade is 2 meter and velocity of flow is 6 meter per second. What is the blade height of section in mm? What is the blade height of section in mm? This is a simple question. This is a simple question. If you have not studied steam turbine, if you have studied basic fluid mechanics, then also you can solve this question. Then also you can solve this question. See what all is given in the question. Flow rate is given to you. How much flow rate is given to you? Flow rate is given as 5 meter cube per second. Diameter of the blade is given as 2 meter. Velocity of flow is given as 6 meter per second. So I can write flow rate is equal to area into velocity. Flow rate is equal to area into velocity of flow. This is the basic formula. This you all should know. Here you will be taking what? Circumferential area, that is pi dh. क्योंकि टर्बाइन से जा रहा है उसके हाइट पे भी डिपेंड करेगा. इट इज गोइंग टू डिपेंड हाइट एज वेल. इनटू वेलोसिटी ऑफ फ्लो. इनटू वेलोसिटी ऑफ फ्लो. So Q is going to be, Q is equal to pi dh into velocity of flow. What is the rate, steam flow rate? What is the steam flow rate? It is 5 meter cube per second into pi. What is the value of dia? The blade dia is 2 meter. H value you have to calculate. What is the value of flow velocity? That is 6. So what is the value of H? Anyone with the value of H? Where are you, Parvinder? We have not this. You should know this. Next question is also same to this one. Next question is also same to this one. Right? So solve this question. These type of questions can be asked in GATE examination because these are the simple formula based question. Solve this question. In now this is reaction turbine, but the formula for flow rate is going to be same. The steam flow velocity. The steam flow velocity is equal to 49 meter per second. Steam flow velocity is 49 meter per second. Blade diameter is 1.8 meter and steam flow rate is 5.4. Calculate the approximately height of the blade at this section. Again you have to calculate the approximate height blade. Approximately blade height you have to calculate. Now again tell me the answer. What is velocity of flow? Velocity of flow is coming as 49 meter per second. It is given. What is diameter of the blade? Diameter of the blade is 1.8 meter. What is the steam flow rate? Steam flow rate is 5.4 meter cube per second. You have to calculate the value of H. You have to calculate the approximate estimate of the height. Approximate estimate of the height H. Right? Please give me the answer. Please give me the answer. Q is equal to, same thing you have to do. Q is equal to pi dh into Vf. What is the value of Q? What is the value of Q? It is coming as H value you have to find. H is equal to Q upon pi into D into velocity of flow. Right? Are you all following? You have to find it in meter. That is why I am here multiplying. You have to find it in centimeter. That is why I am here multiplying by 100 into pi. What is the value of diameter? Diameter is 1.8 into what is velocity of flow? 49. So kitna, it is coming as approximately 2 centimeter. It is coming as approximately 2 centimeter. That is option number B. That is option number B. Next question is very important. Let me see who all can do this question. Let me see who all can do this question. Next question is slightly lengthy, but it is very important. Next question is slightly lengthy, but it is very important. Question number 8. Question number 8. All of you solve this question. In a D level impulse turbine, steam enters with a whirl velocity of 100 meter per second 100 and leaves at a whirl velocity of 9 meter per second in opposite direction, right? If the mean diameter is 0.4 and rotating speed is 2700 rpm, rotating speed is 28, calculate the speed ratio if the blade efficiency is 78%. It is not given as the maximum blade efficiency, it is simply given as the blade efficiency. So just recall the formulas. If you have studied the theory, you need to recall the formulas. I am not here to teach you the theory, because theory classes are already conducted in the morning session. So what is the whirl velocity given at inlet? The whirl velocity given at inlet is VW1. What is that? That is 100 meter per second. What is the whirl velocity given at exit? Whirl velocity given at exit is 9 meter per second. Whirl velocity given at exit is 9 meter per second. What is the mean diameter? Mean diameter is 0.4. What is the rotating speed? Rotating speed is 2700 rpm. Rotating speed is 2700 rpm. Anyone with the answer? What is blade efficiency? Only one student gives me the answer. Blade efficiency is equal to 0.78. Blade efficiency is equal to 0.78. Now they are asking for the blade speed ratio. Blade speed ratio is denoted as rho. It is equal to mean speed of the blade divided by initial velocity, that is u by v1. You have to find the value of speed ratio. Speed ratio is u by v1. Speed ratio is u by v1. So how you are going to calculate the value of u? The value of u is going to be pi d n by 60, which is equal to pi. What is the value of diameter? It is equal to 0.4. What is the value of n? It is equal to 2700 divided by 60. So what is the value of u? U is coming as 56.548 meter per second. We got the value of u. Have you all understood? We got the value of u. Now what is the formula for blade efficiency? It is 2u VW1 plus VW2 divided by V1 square. From here you will be getting the value of V1. What is the blade efficiency given in the question? Blade efficiency is given as 78%, which is equal to 0.78 into 2. What is the value of u? U is 56.548 into VW1. VW1 is 100 plus VW2 is 9. VW1 is given as 100. VW2 is given as 9 divided by V1 square. Anyone with the value of V1? Anyone with the value of V1? Anyone with the value of V1? So the value of V1 is coming as 125.71 meter per second. This is the value of V1. So we got the value of u, we got the value of V1. So what is speed ratio? Speed ratio is equal to rho, which is equal to u by V1. So that is rho is equal to, what is the value of u? 56.548. 56.548 divided by V1, 125.71. So what is the value of blade speed ratio? Blade speed ratio is 0.45. Blade speed ratio is 0.45. That is option number D. That is option number D. Is this clear to all of you? Is this crystal clear to all of you? Can we proceed on to the next question? All of you please tell me, can we proceed on to the next question? Can we proceed on to the next question? Question number 9. A D level turbine has a mean rotor diameter of 0.6 meter A D-level turbine has a mean rotor diameter of 0.6 meter and runs at 2500 rpm. It runs at 2500 rpm. The nozzle angle at inlet is 20 degrees Celsius and blade coefficient is 0.9. Then calculate the driving force on the wheel. Assume equiangular blades and speed ratio to be 0.3. सबसे पहले इसका वेलोसिटी डायग्राम बनाओ. All of you draw the velocity diagram क्योंकि D level impulse turbine दी है. You must be knowing how to draw the velocity diagram of impulse turbine. All of you start drawing the velocity triangle. All of you start drawing the velocity triangle. अब ये velocity how it comes, that is very difficult to explain right now. How it comes, because that is very difficult to explain right now. I will be conducting the theory classes. There I will be teaching you that. So this is the inlet velocity V1. This is the blade speed U. This is the relative velocity VR1. This is the relative velocity VR1. This is V1, VR1, U. If you are going to project it here, right? This is your U. This is your VF1. This is going to be your VW1. This is your nozzle angle alpha 1. This is your angle with relative velocity beta 1. Do you all remember this? Have you all studied this? Yes or no? Have you all studied this? Yes or no? Then from the exit, this is your exit angle. This is the VR2 velocity, relative velocity. This is the U value. This is V2 value. This is V2 value. Then this is your, this much is your VW2 and this is your VF2. VF1, VF2 are the axial velocities. VW1, VW2 are the tangential or the wall velocities. With the relative velocity, there is going to be angle beta 2 and there is going to be angle alpha 2. Long time ago, kya paper, if this question will come in examination, will you say this? If this question is going to come in the examination, will you say this? These things should be on your tips. These things should be on your tips. If you have the subjects which are completed, it should be on your tips. Right? It should be on your tips. If you want the special classes on these, I can conduct. So this is your velocity triangle. Now see what is given in the question. What is the value of rotor diameter? Rotor diameter is given as 0.6 meter. It runs at, what is the value of RPM? The value of N is given as 2500 RPM. The value of N is given as 2500 RPM. Nozzle inlet angle, that is alpha 1. Alpha 1 and inlet angle, that is given as 20 degree. And blade coefficient, the value of K, blade coefficient, value of K, about how much it is given? It is given as 0.9. The value of K is given as 0.9. From now, it won't be necessary. Last uchiha. What do you mean by that? I did not understood. Blade speed ratio is equal to 0.3. Now he is asking for the driving force of the wheel. Do you know the formula for driving force of the wheel? First of all, write the formula of driving force. First of all, write the formula of driving force. You have to take the value of mass. Take the value of mass as 1 kg per second. Take the value of mass as 1 kg per second. In this, mass flow rate is given to you. So what is the formula to calculate the driving force? Driving force is equal to, driving force, I have given you all the values, now you can do. Driving force is equal to mass flow rate into VW1 plus VW2. Now you have to calculate the value of VW1 and VW2. If you can easily calculate the value of VW1 and VW2, then it is very, very simple. then it is very, very simple, right? So first of all, let us focus on VW1. How you can calculate the value of VW1? VW1 can be calculated as V1 cos alpha 1. VW1 can be calculated as V1 cos alpha 1. We know the value of alpha 1. We know the value of alpha 1. Alpha 1 value is 20 degree. But we don't know the value of V1. We don't know the value of V1. But we know the value of blade speed. Blade speed ratio is equal to U by V1. Rho value is given to you in the question. You can calculate it you can calculate by pi dn by 60. So you will get the value of U. From here you will be getting the value of V1. From here you will be getting the value of V1. So what is the value of U? What is the value of U? Come on my dear friends. So it is pi dn by 60. So what is pi? It is 3.14. What is the value of D? What is the value of D? It is coming as 0.6. Parvinder, have you not done these type of questions? What is N? N is 2500. Parvinder, you have not done these kind of questions, kya? Your answers are not coming from your side. These are important, and these are very important as respect to engineering services examination. So what is the value of U? What is the value of U? U is coming as 78.53 meter per second. What is the value of rho? Rho is equal to U by V1. What is the value of rho? The value of rho is 0.3. Value of rho is 0.3. Value of U is 78.53 divided by V1. So what is the value of V1? What is the value of V1? It is coming as 261.79 meter per second. It is coming as 261.79 meter per second. This is the value of V1. Now we got the value of V1, so we can easily calculate the value of VW1. We can easily calculate the value of VW1, that is V1 cos alpha 1. That is V1 cos alpha 1. VW1 is equal to V1 cos alpha 1, right? So what is V1? V1 is equal to 261.79 into cos of 20 degree, which is equal to, what is the value of VW1? What is the value of VW1? Please tell me the answers. It is coming as 246 meter per second. So we got the value of VW1. 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 Now I have to find the value of VW2. Now I have to find the value of VW2. Can any one of you tell me how we are going to find the value of VW2? Can any one of you tell me how we are going to find the value of VW2? Can I write it like this? VW2, go in reverse. Always go in reverse. Whatever you have to find, just write this one. Can I write it like this? VW2 is equal to VR2 cos beta 2 minus U. I know the value of U, which I have already calculated, but I don't know the value of VR2. I don't know the value of beta 2. I don't know the value of VR2. Good evening, Gulnaz, Sadaf, good evening. I don't know the value of VR2. I don't know the value of beta 2. Calculate the value of VR2. Calculate the value of beta 2. U is already there. So what is VW2? VW2 is equal to, yes, VR1, yes, VR2 by VR1 is K. VR2 cos beta 2 minus U. You already know, but it is given in the question. Blades are equally angular. Blades जो है equiangular हैं. तो calculate the value of beta 1. The same value will be for beta 2. Calculate the value for beta 1. The same value will be for beta 2. So how you are going to calculate the value of beta 1? How you are going to calculate the value of beta 1? Can I write it like this? VR1 cos beta 1. VR1 cos beta 1 is equal to VW1 minus U, and VR1 sin beta 1 is equal to Vf1 is equal to Vf1. So from here, can I write tan beta 1 is equal to Vf1 by Vw1 minus u? Are you all understanding? To calculate the value of Vf1, to calculate the value of tan beta, to calculate the value of beta 1. And what is the value of Vf1? Vf1 I can write it as V1 sin alpha 1. It is simple maths. It is simple maths. You have to just manipulate what is not given in the question, how to find that. See, in this question I want the value of Vw2. I know the value of u. I know the value of u, which I have already calculated. That is 78.53. I don't know the value of Vr2. I don't know the value of beta 2. So, but beta 2 is equal to beta 1. Beta 2 is equal to beta 1 because here it is given blades are equiangular. And how to calculate the value of beta 1? Can I write it like this? Again I am telling you, Vr1 cos beta 1 is equal to Vw1 minus u. Vr1 cos beta 1 is equal to Vw1 minus u, and Vr1 sin beta 1 is equal to Vf1 So tan beta 1 is equal to Vf1 upon Vw1 minus u. Tan beta 1 is equal to Vw1 my Vf1 upon. From in this I know the value of Vw1, I know the value of u, but I don't know the value of Vf1. So can I write it like this? Vf1 is equal to V1, Vf1 is equal to V1 sin alpha 1. V1 sin alpha 1. I can write it. So calculate the value of Vf1. Calculate the value of Vf1. Have you calculated the value of Vf1? What is V1? V1 is 261.79 into sine of 20 degree. So what is Vf1? Vf1 is coming as 89.54. Vf1 is coming as 89.54. Vf1 is coming as 89.54. And what is Vw1? Vw1 is 246. So can I write it like this? Tan of beta 1 is equal to Vf1 by Vw1 minus u. So what is the value of Vf1? Vf1 is 89.54. Vw1 we have calculated, that is 246. That is 246 minus the value of u. What is u? 78.53. What is u? 78.53. So what is the value of beta 1? Bologe, what is the value of beta 1? Beta 1 is coming as 28.13 degree, which is equal to beta 2. So we got the value of beta 2. Now we have to, now in this equation we have the value of u, we have the value of beta 2, but we don't have the value of Vr2. Now we have to calculate Vr2. What is Vr2? Vr2 is equal to K times Vr1, because this is the relation, this you must know, because it is given as blade coefficient is 0.9. That is the relative velocity at exit is equal to K times the relative velocity at inlet. So we can write Vr2 is equal to 0.9 into what is Vr1? Vr1 is Vr1. What is Vr1? Can I write it like this? Vf1 is equal to Vr1 sin beta 1. That is Vr1 is equal to Vf1 by sin beta 1. I know the value of Vf1, I know the value of sine beta, right? So Vr1 is equal to Vf1 by sine beta 1. Anyone with the value of Vr2? Anyone with the value of Vr2? It is coming as 170.92 meter per second. It is coming as 170.92 meter per second. It is coming as 170.92 मीटर पर सेकेंड. तो VR2 आ गया. अब VR2 आ गया तो VW2 निकाल लो. VR2 आ गया तो VW2 निकाल लो. So VW2 is equal to VR2 cos beta 2 minus U. So VR2, what is VR2? VR2 is 170.92. 170.92 cos of what is beta 2? 28.13. 28.13 minus the value of U. What is U? 78.53. 78.53. Are you all understanding? Most of you must have not studied the theory of it. I know, and you are preparing for the examination. So what is VW2? VW2 is 72.2. So I got the value of VW1, I got the value of VW2. So what is the driving force? What is the driving force? Driving force is equal to mass flow rate into VW1 plus VW2. Mass flow rate you are going to take 1. VW1 is equal to 72. VW1 is VW1 कितना है? 246 plus 72.2. What is the answer? The answer is coming as 318.21 kilowatt. The answer is coming as 318.21 kilowatt. That is option number C. That is option number C. Is this question clear to all of you? Is this question clear to all of you? Is this question clear to all of you? बोलोगे? Crystal clear, diamond clear, platinum clear. ड्राइविंग फोर्स का यूनिट इसलिए है ना, VW1 प्लस VW2 का यूनिट ये आपका रहेगा V स्क्वायर है ना, सॉरी V स्क्वायर नहीं है, V है, वेलोसिटी है. ये आएगा आपका kg पर सेकेंड में और ये हो जाएगा किलो जूल पर kg में. अच्छा वेलोसिटी है ना, हाँ सही बोल रहे हो, एक मिनट रुकना. नहीं रुक जाओ एक मिनट. कहाँ क्या क्लियर हुआ? क्या क्लियर हुआ परविंदर? मुझे ही बताना जरा. केजी मीटर पर सेकंड क्या होगा? न्यूटन पर सेकंड. इसका किलो न्यूटन होना चाहिए यार. ये किलो वॉट नहीं होगा. टाइपिंग मिस्टेक है, टाइपिंग मिस्टेक है, टाइपिंग मिस्टेक है. किलो वाट नहीं होगा, न्यूटन में होगा. ये ड्राइविंग फोर्स न्यूटन में होगा ये, राइट. एक बार देख लेना, एक बार देख लेना इसको. अरे ठीक है ना, मास इंटू एक्सेलरेशन, ये न्यूटन में होगा. वहां पे क्या आया हमारा? मास इंटू वेलोसिटी. वेलोसिटी के यूनिट्स क्या होते हैं? मीटर पर सेकेंड. और ये क्या है? केजी पर सेकेंड. केजी पर सेकेंड, तो ये क्या हो जाएगा? दिस इज गोइंग टू बी केजी मीटर पर सेकेंड स्क्वायर. दैट इज मास इनटू एक्सेलरेशन विच इज इक्वल टू फोर्स. इट इज गोइंग टू बी इन किलो न्यूटन, किलो न्यूटन, किलो न्यूटन, राइट. केजी मीटर पर सेकेंड स्क्वायर होगा, राइट, यस एन होगा, गुड 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 परविंदर, गुड, टाइपिंग मिस्टेक हो गई है वहां पे, ठीक है। सो वी विल बी मीटिंग at 10:30 after 45 minutes in Hindi channel with some more questions, right? So thank you all of you, bye bye, take care, love you all.